Now coming to the VSEPR theory. So in this particular theory, we have already studied the postulates of the VSEPR theory. Now I said you in the last AV that the VSEPR theory is used to find the shape of the molecule. We need to find the shape of the molecule from the VSEPR theory. Now how it is? How it is so? Because we have studied in VSEPR theory, basically in one line if I say that the molecules, the atoms, they rearrange themselves. It sets itself in such a manner, alright, so that the force of repulsion among them is minimum. Alright, due to which they have a definite bond length, they have got a definite bond angle, alright, they have got a definite bond energy, and hence they have got a definite geometry, which is called as the shape of the molecule. So here we are having two types of geometry. One is your regular geometry, another is your distorted geometry. Regular geometry, geometry means shape, I have already said it here, and another is your distorted, that is distorted. One is your regular, another is your distorted. Alright, let me write it in this way, it is better. That is regular geometrical figure and another is your distorted geometrical figure, so to say. Now what is the difference between regular and distorted? Regular means which has got a definite shape, alright, which has got definite shape, clear? Distorted means it has got a shape but not what you can say the actual shape of the molecule, means it has got some other shape of the molecule compared to that particular bond angle, alright, compared to, for example, let me say you'll be confused, let me simplify it further. Suppose if the bond angle is, that is 109.5 degree, alright, then what it should be? Tetrahedral. Tetrahedral the shape is. Tetra means 4 planes will be there, alright, but what you find is that if the bond angle is slightly decreasing here, then the shape is not tetrahedral, it may be bent, it may be pyramidal, so this is called distorted. This is called distorted. It has got same number of pair of what you can say electrons. Same number of pair of electrons. Of course, the bond pairs and the lone pairs will differ, no doubt about it. But the same number of pair of electrons in regular geometry also, in tetrahedral also, it has got 4 pair of electrons. We can say that here also we are having the 4 pair of electrons. But in regular geometry, now I will come to the difference. But in regular geometry, what I said you, we have got a definite bond length. Alright, we have got a definite bond angle. We have got a definite bond energy. That means the central atom is attached to a particular kind of atom, one type of atom only. The central atom is attached to one type of atom only. Alright, so hence in case of regular geometry we can have the, what you can say, I have told you already, the central atom is A and the surrounding atom is B, so we can have AB2, means which shape it is? Linear. This is linear, AB2. Bond angle is how much? 180 degree. Bond angle is 180 degree. Alright, what I said you, the shape is linear. Similarly, if it is AB3, then what is that? It is trigonal planar. This is your trigonal planar. See, this is AB3, it is trigonal planar. Now, bond angle is how much it is? 120 degree. What I said you, this is trigonal planar. So, it is AB3, we can say that. Clear? Next is, means you are having, that is A is the central atom and B is the surrounding atom. Understood? Here, B is that is nothing but what? Surrounding atom. See here. Means if B, it forms bond pair with the central atom. Alright, so hence I said in case of regular geometry, we are having a central atom, we are having a one kind of, what you can say, surrounding atom. One kind of. For example, we can have here, in case of tetrahedral, CH4, we can have here CCl4, alright, we can have here CO2, alright, we can have here BeCl2, in case of linear, CO2, BeCl2, we can have it, clear? But same thing when it becomes a distorted, having the same number of bond pairs, then what it will be? Instead of, what you can say, what I said this one is trigonal planar, this AB3. How it is trigonal? So you just join it by dotted line. Dotted line means this line does not exist. Okay, so hence this dotted line. Wherever you will find the dotted line means that line actually does not exist. Just to know about a definite shape, we have done a dotted line. Alright, so in this way, don't think we are having AB2, AB3 only. No, we can have, that is AB4, alright, we can have AB5, alright, we can have nothing but, we can say this like AB6, we can have AB7. Now here this is not the example. Trigonal planar example is not CH4 and CCl4. Let me tell you. Alright, this is an example of tetrahedral. Tetrahedral means what is the geometry it will be? What is the shape? AB4 it is. I don't have a space, so I did not say you. Trigonal planar will be something else. Alright, in case of trigonal planar, we can have some other molecules. What is that other molecules we can have it? Like we can have here, that is nothing but aluminium chloride. Alright, because aluminium chloride, even if it's an ionic compound, but it behaves as a covalent compound. So we can have aluminium chloride, AlCl3. We can have what you can say BF3. We can have SO3. We can say that. Clear? We can have SO3. We can have AlCl3. We can have BF3, which comes under what you can say trigonal planar. We can say, and AB4, that is CH4, CCl4. Similarly, we can, I said AB5 is there. Okay, I'll come to it later on, one by one. Alright, so just I was differentiating. So hence on this particular note, we can say that here suppose we are having apart from bond pair, we are having lone pair also. So distorted geometry means apart from bond pairs, we also have got lone pairs. Means surrounded atom, the central atom is not surrounded by a particular kind of atoms, a definite kind of atoms. It is surrounded by different kind of atoms also. Means the central atom is not having only one pair of bond, one particular kind of bond, that is a bond pair. It is also having lone pairs also. I said you lone pair. What is a lone pair? I have told you. Lone pair means pair of electrons which does not participate in bond formation. So in case of AB2, we cannot have a lone pair. Understood? We can have linear only, regular geometry. In AB3, the distorted geometry of AB3 can be also AB2L. See here, number of bond pair, number of pair of electrons remains the same. Already I said you. Number of pair of electron remains same. How many pairs it is? 3 pairs. You can see. Here also 3 pairs, 2 bond pair but 1 lone pair. So it is distorted. That means what we can say, that when the central atom is surrounded by different kind of atoms, then it is coming under distorted geometry. Like here I said CCl4. What is the example I can give it here? Got it? What is the example I can give it here? Like AB4 it is. Understood? AB4. Clear? So what is the distorted geometry of AB4? It can be, it can be AB3L, it can be AB2L2. For AB3, this is a distorted geometry, AB2L. I am coming to the name, don't worry. For AB4, this can be the distorted geometry, that is AB3L and AB2L2. Means, see, number of pair of electrons remain the same. Again and again I am saying. Here also 4, here also 4. Here you can 3, here also it is you can 3. You can compare it. Number of pair of electrons remains the same. Alright, but here we are having only a particular pair, means particular kind of atoms. We are having a definite kind of atom, due to which the bond angle, the bond length and the bond energy is same, is identical. Because here we are having only one particular kind of atom. You can see the example. Al is a central atom and Cl. This is Cl, this is Cl, this is Cl. Alright, BF3, this B is a central atom, F. That's it. Alright, that's it. But when I say AB2L, then we are having different kinds of atoms attached to it. Different kinds of atoms. If not different kinds of atoms, then we'll be having different types of bonds attached to it. Means here we can see single bond. Here you can see that. Here you can see, or also here also you can say, apart from single bond, you will be having multiple bonds. So when multiple bond will be there, definitely bond length is going to differ. Because what I said, the bond length is same, the bond angle is same, the bond energy is same, due to which it is regular. And also the central atom is attached to a particular kind of atom, due to which the bond length, bond angle, bond energy, again and again I am saying you, it is same. But here it is not attached to the same kind of atoms, it is attached to different kinds of atoms, you can say that. That is the example what I am giving you. Got it? That is the example what I am giving you. So when it is AB2L, here like AB3, the shape is what I said you, this trigonal planar. If it is AB2L, what is the shape it is? Bent shape. Bent or V-shaped. V shape, victory. Alright, V-shaped, we can say that. Now what is the example we can give it here? Like, we can give the example as SO2. Now you might be thinking SO2, how it is? See here. S, one double bond and one single bond with oxygen. See here, same oxygen atom. One oxygen is attached to single bond with sulfur and one other oxygen is attached to double bond, and we are having, that is a pair of electrons, we are having it here. Alright, in this way we can have SO2, we can have NO2 also. Instead of S you put it here N, we can have NO2 also, we can have it. Clear? So in this way, you can say that it is coming under what? Apart from bond pair, it is also having lone pair. So hence it is AB2L. Alright? Clear now? So apart from single bond, we are having double bond also. Multiple bond is also being there. So bond length, is it identical? No, it is not the same. Bond angle, will it be identical? No. Bond angle, will it be identical? No. Definitely no. Because if you draw an imaginary line here, this angle and this angle, will it be same? No, it will not be same. It will be different. Alright, so in this way, when the bond angle, the bond length, the bond energy is differing. Got it? Then that particular geometry is known as distorted or irregular geometry. Similarly, let me come to AB3L. We can say that. Alright, let me come to AB3L. So AB4, you learnt it CH4, CCl4 in this way. So AB3L, that was, I was going to give you the example. That is nothing but it will be CH3Cl. See, 4 bonds. CH3Cl. We can say that. Clear? So different atoms it is attached to it. So definitely the carbon which is attached to hydrogen, listen carefully, the carbon which is attached to hydrogen and the carbon which is attached to chlorine, is the bond length the same? Carbon chlorine bond and carbon hydrogen bond, is the bond length same? No. Alright, because carbon is a central atom and hydrogen chlorine is a surrounding atom. So carbon hydrogen bond, 3 bonds with hydrogen and 1 bond with chlorine, are the same? No, it is different. The bond length is differing, due to which the bond angle will differ, due to which bond energy is going to differ. Alright, so when they are having different bond length, bond energy, bond angle in this in the same molecule, then it is called as distorted geometry. So AB3L, we can give the example. Similarly, AB2L, we can give the example. Is very simple example is what? Water. We can give it. That is water. We can give. How it is water? Because you can see 2 pairs. You can see another 2 pair is your lone pair. These 2 are the lone pair. I hope so. You are able to understand it. Or let me rub it this one. Otherwise you will not be confused. See, it is 2 lone pairs. So what else are having? We are having 2 bond pairs and 2 lone pairs. Because oxygen is having what you can say 2 pair of electrons which is not participating in bond formation in case of water molecule. Due to which water is bent shape. It is having a distorted geometry. Alright, so this question will come in your exams, in the reasoning questions. That water H2O, alright, it has got a distorted geometry. Its bond angle is 104.5 degree instead of 109.5 degree of a regular tetrahedron. Alright, regular tetrahedron is, let me rub it this one so that you will understand it. Regular tetrahedron is this. This is a regular tetrahedron, AB4 molecule. AB4. It is 3-dimensional, mind it is 3-dimensional. Okay, it is not 2-dimensional, 3-dimensional. This is regular tetrahedron. The bond angle is 109.5 degree. What I said, 3-dimensional, mind it. So don't try to count here that the angle at a point is 360 degree. How it is possible? It is 3-dimensional. It is not 2-dimensional. Understood? Yes. So in this way, what we find is here, it is the regular tetrahedron. The bond angle is 109.5 degree. But in case of water, the bond angle is deviating from 109.5 degree and it becomes 104.5 degree. Why? Answer is very simple. Because in regular tetrahedron, we are having a particular kind of bond. What is that? Only bond pair. But in case of water, apart from bond pair, we are having 2 lone pair. The lone pair repulsion, listen carefully. The lone pair repulsion is greater than lone pair bond pair repulsion, which is greater than bond pair repulsion, due to which the bond angle slightly decreases. Because see, this is going to repel. When this is going to repel, now this will go far apart from each other. Alright, when this is going to repel, so this will go far apart. When this is going to go far apart, then this and this is going to repel, and here this, what you can say, this will not be here, it will come here and this will come here, and this is going to repel. Means the lone pair here and the lone pair and the bond pair here is going to repel. Again the lone pair here and the bond pair here is going to repel. Now, so that the bond pair, you will think it will come closer? No, because again the bond pair and bond pair is also going to repel. Alright, so you are having, what is the repulsion here? Lone pair repulsion, lone pair repulsion, bond pair repulsion. But which repulsion is greater? Lone pair repulsion is greater. As these repulsion is greater, so the bond angle will come closer. So instead of 109.5 degree, the bond angle will be slightly less, which is 104.5 degree. Understood? Here only one kind of bond is there, that's bond pair, but here it is two lone pair. So this will repel. When this is going to repel on another, now this is going to repel with this, and this is also going to repel with this, due to which it will come little bit closer. From 109.5, the bond angle is slightly decreased to 104.5 degree, and hence the bond angle decreases. Alright, the bond angle is decreasing. So this question may come, that why the bond angle of water is 104.5 degree instead of 109.5 degree of a regular tetrahedron. In case of water molecule, we are having two lone pairs, and the lone pair repulsion is greater than lone pair bond pair repulsion, which is greater than bond pair repulsion, due to which the two bond pairs, they come closer to each other compared to a regular tetrahedron, and thus the bond angle of water slightly decreases, and which is 104.5 degree. Alright, clear? In this way you will be getting the reasoning questions. Clear? So in this way you can see that the distorted geometry is there. Alright, so we have discussed AB2, we have discussed AB3, we have discussed AB4, we have discussed that is AB2L2, AB3L in this way. So regular geometry and the distorted geometry we have seen it. So for distorted geometrical figure, what you need, that the central atom should be attached to different kinds of atoms. Central atoms should not have only one type of bonds. It can be single bond as well as multiple bond, due to which bond angle, bond length, bond energy, everything is going to differ. Bond length, you understand what is the difference? What is a bond length? It's nothing but from one nucleus, from one atom to another nucleus, another atom. The distance between them, that is called as the bond length. Alright, what is the bond angle? Between two bonds, the angle which is being made along with the central atom, that is called as a bond angle, we can say that. And what is the bond energy? The amount of energy which is required for the formation of that particular bond or for the breaking of that particular bond is known as bond dissociation energy, we can say that. That is called as bond dissociation energy, or we can also say bond formation energy. For making up a bond, whatever the energy, what you can say, is being released. For the making of the bond, always know that energy is released. For the formation of new bond, energy is released. Alright, but for the breaking of a bond, energy is, what you can say, absorbed. We require energy. To break this pen, I require energy. I require. So that is endothermic. So let us say this is a bond. I want to break this bond. So this is known as bond dissociation energy. The amount of energy required, I will say. But for the formation of this bond, I will say the amount of energy released. So for the formation of 1 mole of that particular bond is known as the bond energy. Alright, in this way. So basically bond energy means, we always mean to say bond dissociation energy. Means what is the energy which is required for breaking of that particular bond. Basically. Alright, but it can be also for the formation also. It can be also. Alright, which you have studied in periodic properties, we have studied already. Alright, clear about it. So, understood now what is bond length, what is bond angle or bond energy, or you might be thinking of that, what is bond length? What is bond angle? What is bond energy? Very simple. Alright, the definition is, and I have told you already. Now, next is, if it is, what you can say, that is, I said you already, that AB3L, another example I will give you, one more example is coming in my mind, that is AB3L, it's a very important one, for that reason I am discussing this with you, AB3L. So, it will be NH3 molecule, NH3, ammonia, Cl, AB3L. A, these are 3 B's and this is 1 L. So it is AB3L. What is the name of the structure? Pyramidal. It is pyramidal, AB3. One of the example of AB3L molecule is pyramidal. AB4, you know that. It is tetrahedral. AB2L2, I told you, it is bent shape or V shaped. And AB3L, what is that? Pyramidal. So are we having only one molecule? No, there are several molecules. Just one example I am giving you. But you don't think that one molecule is there. It can be, what you can say, PCl3, it can be, that is NCl3, or it can be NH3, or it can be NF3, it can be PH3, so many we can have it. Alright, clear? It can be H3O plus also, alright, hydronium ion, alright, also it comes under, that is pyramidal. We also call it as trigonal pyramidal, also we say that, no doubt about it, trigonal pyramidal. Now, here the bond angle is 107 degree. 107 degree the bond angle is. Again it is less than the tetrahedron. Again the question may come that why ammonia is having a bond angle of 107 degree less than the normal tetrahedron which is 104.5 degree. Because in ammonia, what you find is that apart from bond pair repulsion, we have also got lone pair bond pair repulsion, due to which Got it? Due to which, not 104.5 degree, I'm sorry, it is 109.5 degree. I'm sorry, 104.5 degrees water. Got it? Yeah. So, again, let me repeat my question, that why ammonia is having a bond angle of 107 degree, got it, compared to the normal tetrahedral of 109.5 degree. I'm sorry, previously I said 104.5 degree, that is of water I said by mistake. Got it? So, in this way, why? So, what you will say is that in ammonia, apart from bond pair, we are also having lone pair bond pair repulsion, due to which the bond slightly comes closer to each other, and hence the bond angle decreases from 109.5 to 107 degree. Because you know, again and again I am saying, a normal tetrahedral, we are having only bond pairs, we don't have lone pairs at all. Got it? So it can also come that why the bond angle of water is less than that of ammonia, because in water you have seen it, apart from what you can say bond pair, we are having two lone pairs, but here only one lone pair is there, due to which we don't have lone pair repulsion. For example, in water we have what you can say, the lone pair repulsion is there. So there is a lone pair repulsion, and lone pair repulsion is greater, due to which the bond angle decreases to how much it is, 104.5 degree. But here we are having lone pair repulsion, and you know that lone pair repulsion is less than lone pair repulsion. Lone pair repulsion is less than lone pair repulsion. So as this repulsion is more, it will repel more, so it will come closer more, due to which the bond angle is decreasing more from 109.5, it is decreasing to 104.5. But here, compared to water, listen carefully, compared to water, their repulsion is less, because here it is lone pair repulsion. The repulsion is less, so the bond angle decreases. From 109.5, bond angle decreases, but not as much as water. It decreases slightly to 107 degree. Got it? Because again I repeat, we are having lone pair repulsion, which is greater than lone pair repulsion. And hence for that reason, as the repulsion is more, so the bond angle decreases more. Here the repulsion is less compared to water, the bond angle is, what you can say, it is greater than that of water. Got it? So these all questions will be coming. These all questions will be expecting it, all these questions. Clear? In the reasoning questions, in the VSCPR theory, you will be expecting these all questions. Clear? So this is about your different types of molecules and the reasoning questions I discussed with you. So more I am coming to it.